right, so this one again is calculator question. And this is particle motions. This is going to be our velocity, acceleration, et cetera, et cetera. So a particle is moving along the x-axis. This is its velocity equation. So that's the rate. They don't give units for this one. So you don't have like feet per second or anything like that. So you don't have to worry about units, which is kind of nice. The particle is in position -5 at time 0. So that is your initial condition. So letter A, find the acceleration of the particle at time 3. So if this is velocity, to get acceleration, we're going to do the derivative and then plug in 3. So you would do the derivative of this and then plug in 3. Now, the calculator allowed, so we're going to use the calculator for that. And your derivative is math 8. We use math 9 a lot for the integral, but you can also do derivative, math 8. So d dx, this is what's going to get put in there. That's actually not bad as far as these functions go. This one's not actually too terrible to type here. All right, and then it'll be such that x equals 3. Again, make sure you are in radian mode. This one has sine in it. If you're not in radian mode, it's not going to come out right. All right, so we get -2.118. That's all they asked for. They didn't ask for anything else. That was it. And I just realized I forgot to go over the points for the previous question. When I go over the points for this one, I'll go over the points for that one too, and then it'll be in the same video. Geez, I can't believe I forgot to do that again. All right, letter B, find the position of the particle at time 3. All right, so you're going to take where it started, which was -5, and then add on the displacement. Now this time does begin at 0, so we're going to do integral from 0 to 3. But just be aware, it's not always 0. They could have said time whatever, and you would just put that number there. So it's initial condition plus displacement. So that's what we're going to type. So this is -5 plus integral 0 to 3. And then I'm going to have to type that function again. But again, this one's not too terrible. So -5 plus integral 0 to 3 of all of that dx. And that will give you your answer. So -1.760. You do need that 0 for it to be 3 decimal points. All right, letter C. Evaluate this and this. The only difference is one has an absolute value and one doesn't. Interpret the meaning of each integral in the context of the question. It's weird that they're asking for that because there aren't any units in this problem, but oh well, we'll still write a sentence. All right, so doing this first one, oh, whoops, that equals. And can't write and talk at the same time. All right, so for this first one, all you have to do is integral from 0 to 3.5. I'm gonna go back and bring this back again so that I don't have to recopy the entire thing. I'm just gonna change the 3 to a 3.5 and then delete this -5 plus out front because it's not asking you for an initial condition. So just 0 to 3.5 of all of that gives you 2.843. And then we're going to write a sentence for that. So what is this? What does this mean? This is the what? It begins with a D, everybody. And actually, it's a word that I just mentioned like a minute ago. I'm going to throw this question to you guys, though. It is the what? What is our vocabulary word for what that is? Starts with a D. Good, awesome, you guys rock. That is displacement. And here's where I think this question is kind of weird that they asked this. Normally you would say this is the displacement in feet or in miles or in whatever, but there's no units. So it's just, this is the displacement, but you have to say from 0 to 3.5. And again, usually it would be from 0 to 3.5 seconds or minutes or hours, but they didn't give you any units. So that's just it. It's weird that they're asking for you to explain that when there's really like no explanation. There's no context in the problem. But anyway, now we're going to do the same thing for this one. Now this one you are going to have to retype the whole thing because you can't just like shimmy an absolute value in there. All right, so absolute value, and then I'll type this whole function. Again, I don't have enough space on the screen to show everything. So if you have these open in another tab, you can see it. And again, if I'm typing it too fast, you can always watch the video again later, pause it, slow it down. I want to make sure that I finish all of this, so you go over all the questions. All right, so this one might take a second. Sometimes for the absolute value ones, it's a little slower. All right, so 3.737. And it's going to be almost the exact same statement, except instead of this is the displacement, this is the what, guys? I only heard from like 2 people on the last one. Let me get a few more responses here. This is the what? If it's not displacement, when you have the absolute value, what is that? Good, nice job, guys. Perfect. Total distance. All right, this is the total distance from 0 to 3.5. And again, I have no idea what the exam is going to look like this year with it being on the computer, but I think you're going to do a lot of this explaining and typing in a sentence kind of thing, because they're having you type in all of your work. Nothing is going to be like uploaded from a picture. So I think you're going to do a lot of justifying and explaining like in words. So get used to writing those sentences. All right, letter D. Now we're introducing a second particle is moving along the x-axis with this. Okay, be careful. For the first one, they gave us velocity. That's a rate. For this one, they're giving us position. That is not a rate. That's just the original function. All right, at what time are the 2 particles moving with the same velocity? All right, so we want to set the velocities equal. So we want to have this velocity, v of t, equal to this velocity. And to get from position to velocity, you need to do a derivative. So this derivative would be 2t minus 1. And so what we're going to do is put this into y1, this into y2, and calculate the intersection. So I'm clearing all this out. All right, that velocity is getting put into y1. And then 2x minus 1 gets put into y2. The window that they gave us is 0 to 3.5. So I'm going to make my window 0 to 3.5. I'm going to make the y negative 10 to 10. I actually don't know what they need to be here. I don't really have any indication of what it might need to be. So I just made it standard. We can always change it to something else. But we're just looking for where these intersect. All right, so they intersect somewhere in there. So I am going to change my y window. I'm going to bring this in. Let me make it like 0 to 5. We'll see if that's good enough. You kind of just need to mess with it until you're happy. I'm going to make it 0 to 5. Let's see if that's good enough. I can always shorten it again. There, that's good enough. We can see there. All right, so here is our intersection. I'm just going to calculate that. So calculate intersect. First curve, second curve. Guess doesn't really matter so much for this one because there is only one intersection. But if you want to move the cursor closer to that, you can. Hit enter, and that is your answer. So 1.570. All right, so let me go over the points for this one, and then I'll go back and go over the points for the first one as well. I'm sorry, I forgot to do that. They do add up to 9. So I want you to give these a try and then kind of score yourself, right? So for the first one, that was just worth 1 point. But all you had to do was type it into Math 8. So that was only worth 1. This next question, you get a point for using the initial condition. So if you have -5 plus whatever, you get a point for that. You get a point for setting up that integral, and then you get a point for the answer. That was awesome. Basically, you got that question. You got 3 give me points here. This one, it was 1 point for both of those answers. So I hate to tell you, if you messed up one of them by 1 decimal point, they would take off the whole point. Like if this one was right, but this one was off, like if you wrote 0.739 by accident, they would take off the whole point. They don't do partial credit. All right, and then it was 1 point for this explanation and 1 point for that explanation. And again, I think you're going to do a lot of sentence writing with this exam this year. All right, part D, you get a point for setting these 2 equal and then a point for the answer. All right, and I always just like to make sure I got all the points. That adds up to 9. All right, so for the first one, and I'm sorry I forgot to go over this in that video. So for this, you get a point for setting up this integral and a point for the answer, 270 people. Here, you get a point for subtracting off the people that are leaving. They made it a point for that, and then a point for the answer, because you already did this in part A, so I think that's why they put the point there. For part C, that is only worth 1. You just get 1 point for that answer, which I don't know. I feel like that maybe should have been worth 2, but no one asked me my opinion. All right, for part D, you get a point for setting these derivatives equal to 0. But if you just intuitively set the rate in equal to the rate out, they're going to give you that point. So you get a point for that. You get a point for identifying the critical points. You get a point for doing the whole chart, because that's your justification, and then you get a point for the answer.